Warm-up says, what are the coordinates of P, that's at negative 5, 3, that have been reflected over the x-axis? So looking at your formula rule, your formula chart, what is the formula for reflecting over the x-axis? What changes? You have the xy, if you're looking at your green formula chart. Which one changes, the x or the y? The y. So x stays the same, y changes. So if I apply that to the point, my p prime would end up where? Negative 5, negative 3. All right, so there's your point for p prime. All right, looking at the one underneath, it says, what are the coordinates of point R, that's at 0, negative 7, that have been reflected over the y? So again, looking at your equation, this would be xy. When it's the y-axis, the x changes, but not the y. So what would be the coordinates of R prime? 0, negative 7? Correct. You can't change the value of a 0, so that's just going to stay 0. All right, let's go on to today's. So today's we're looking at translation. We'll be looking at translation today. So the translation is when we are sliding the object. You're just sliding it over. The vector form is the same thing as our coordinate rule. Then these are the rules that we're using to actually move it. The way you want to read it is if it's telling you to add an A, all right, you're going to be going toward the positive direction. What direction are the positive numbers on the x-axis?
Up and right.
On the x-axis only? Would be only to the right. So just the right. No, you're right, but we're not there yet. But on the y-axis, if I'm adding, we would be going up, right? So you're just going to read them, whether they're positive or negatives. If you're counting, this is how you would read it so that you can move it. The vector form is the same thing. The only difference is that you don't have the x and you don't have the y. The values are still the same. A is still A, B is still B. They're just without the x and the y, okay? All right, so we're going to do it algebraically. So here it says, given that the coordinates for the pre-image and the image of the triangle are as t, if every point is translated to the left 4 units and then up 2 units. So if I'm going left 4 units, am I adding or subtracting if I'm going left? Subtracting. So that's x minus 4. And if you're going up, are you adding or subtracting? Adding. So it'll be y plus 2. All right, so if I get the original coordinates, r is at 2, 1. S is at 5, negative 3. And t is located at negative 1, negative 4. All right, so all I'm going to do is I'm going to take the rule, and I'm going to place it right here. X minus 4, y plus 2. So all I'm going to do is plug them in. Whatever your x is, I'm going to plug it in here for the x. So I'm going to write 2 minus 4, comma. And I'm going to do the same thing with the 1. So wherever 1 is, I'm going to plug it in with the y. So I'm going to write 1 plus 2, and that'll get you your new point. So if I do 2 minus 4, what would be my new x value? Negative 2, and 1 plus 2 is 3. All right, we do the same thing with the next one. We have 5 minus 4, and then we have negative 3 plus 2. What's 5 minus 4?
1.
And negative 3 plus 2 is negative 1. All right, next one, we have negative 1 minus 4. That gives us negative 1 minus 4, negative 5. And then what's negative 4 plus 2? Negative 2. All right, so if I graph these points onto the graph, I'm going to graph negative 2, 3. So negative 2, positive 3. That would be my R. Then I'm going to graph 1, negative 1. That would be my S. And then negative 5, negative 2, that's going to be my T. Now, your triangle should look the same. So the graphing piece just kind of lets you see, are your points correct? Right? All I did was slide it over. Now, mind you, initially it said left 4, up 2. So I can count left 4, 1, 2, 3, 4. And then I can count up 2, 1, 2, and you get to that point. So again, starting at your pre-image, 1, 2, 3, 4, up 2. 1, 2, 3, 4, up 2. And just like I counted, you can initially do that, but you won't always have the graph, so it's always great to practice the algebra piece, which is what we did. All right, the bottom one reads, The vertices of triangle ABC are the following. Without graphing, give the coordinates of the image of B after the translation of the vector -1, 4. You read the vector the same way. It's x minus 1 and y plus 4. You read it exactly the same. So all they're interested is in B. So our focus is only B. It's 4, 2. So what would I substitute in? What would it look like after the substitution?
3, 6.
All right, so he says 3. And then 2 plus 4, he says 6. And then that would be your B prime. Bless you. Bless you. Remember, after your transformation, the letter indicating our point, right, whatever the variable is, you're going to be putting that prime notation, noting that that was after that first movement. At the end of the notes, we're going to do multiple movements. All right, let's look over to the right side. All right, let me have you guys try those two, just to get that practice in. All right, so looking at the first one, given the triangle, and I gave you the coordinates for R, S, and T. Again, what you want to do is you want to take that rule, and you can start here, right? It says every point, those are your points, will change so that we subtract 3 from X and we add 2 to Y. And then that'll get us our image. Now, some of us can mentally do it, right? If we can't, just take your time. There's no rush. Better you guys take your time than rush through it. This is going to be 2 minus 3. 1 plus 2. What did y'all get for the R prime? -1, 3. All right, so then we had 5 minus 3. -3 plus 2. What did y'all get for that one? 2, -1. And then we had -1 minus 3. And then -4 plus 2. -4, -2. All right, and then we can graph it just to make sure that it is that the triangle did stay the same, right? That nothing was off. The bottom one says, given a triangle without graphing, find the coordinates of only C. So we're focusing only on the C point, and this is your vector. What did y'all do to that 2 and that 4? Added a 2, and then added a 7. Good. So then C prime would end up where? 411. All right, so on the homework, I may just be asking for 1, just depends on the question. Okay, so that was the movement. Now it says, write the coordinate rule for the translation of DEF to DEF prime in coordinate notation. So first thing y'all need to do is go through and say, okay, which one's the new one? Is it the one on the left or the one on the right? The one on the right, because it has the prime notation, yeah. So this was your new. This one was the original. All right, you can pick any point. Pick any point y'all want. Do y'all want D, E, or F? E. All right. So as you're doing this, you need to make sure you start at the original and you go your way to the new one. It's like you're driving. What direction are we going to go? How do I get from this E to that E? Go up. And right. All right, how many units up? 3. Up 3. And then over 5. Is that am I adding 5 or subtracting 5? I'm going to the right side. Adding 5. Okay. Once you found those, you need to know which one changes the X. The one that changes the X is the one parallel to the X-axis. So when I write my rule, what am I doing to the X? Adding 5. And then to the Y, I'm adding 3. Okay, so just remember, it's the one so this one is parallel to the X. So those two go together. And then same thing with the other ones. 3 is parallel to the Y. All right, if I write this same rule in vector form, all you do is you take away the X and the Y. So you write these brackets that look not really like brackets, but like sideways V's. And you write just the number. It's a +5, comma, a +3. Right, +5, +3. All right. In example 3, it says finding the preimage. So here's the rule that they used. They used X plus 4, Y minus 7. It says here are the new points, right? Here's the image. The question is, what were the original points? What was the preimage? So what do y'all think we need to do to figure out what that original image was? Opposite what it's telling us to do. So what would be the opposite? -4 and +7. All right. So then you take your points. You're going to take P. You're going to -4. So you're going to do -3 minus 4, and then 4 plus 7. That's going to get you the original location of P. Same thing with the Q. We have 2 minus 4, and then 1 plus 7. Where were the original points of Q? So what did y'all get for P?
Negative 7, 11.
Negative 7, 11. And then for Q, we got
Negative 2, 8.
negative 2, 8. All right, go ahead and try that bottom one. Okay, so if you notice there's nothing with the x, right? What does that mean about the x? Nothing, that nothing's happening to it. That's all it means. Nothing's happening to the x. To the y, you need to, instead of adding the 8, you need to subtract the 8. So what would be negative 1 minus 8? Negative 9. And then that would be the location of the original m. Okay, so if there's ever anything that's, if there's ever the x or the y without anything being added or subtracted, that means you're leaving it alone. That means that didn't change. Okay, all right. Last one. The last thing we're looking at is the double transformations. So and if you look closely, and we're just going to talk about what happened, if I'm going from A to A prime, and the only ones we've studied so far have been reflection and translation. Did I reflect it or did I translate A to A prime? Translate, good. So on that first one, we're going to write translate. So what was the transformation? We're going to say a translation. And then you went from A prime to A double prime. Was that a translation or a reflection? That one was a reflection. All right. So a composition is when you have multiple transformations happening to a point. Now with this one, to me, it's easier to do it all algebraically. So here they want us to find the coordinates after the translation and the reflection over the y. And I already have everything written for you. So this is how I would write it out if I was you. But you can do it however you'd like. You can count if you want. So for my first thing I'm going to do is translate it. My x doesn't change. So I'm going to come here and I'm going to say, okay, that doesn't change. My x is fine. For the y's, I'm going to add 4. So what's negative 3 plus 4? Positive 1. What's 0 plus 4? 4. What's negative 4 plus 4? 0. Okay, once you've taken the step forward, you don't go back. Now when you do the next one, this one is based off of the new points. So you keep going. What's going to happen to, okay, so what some of you may want to do, and it may help some of you, so if y'all can go straight to it, that's great. If you notice, the x and the y are going to stay in the same position. The only thing changing is the x. For some students go directly to it. Others say, okay, let me write it down first because I know they're not moving. And then they go in and they're like, okay, so that turns into a positive, that turns to a positive, that turns to a positive. And then they get their final answer. That's all it is. You just have to change the sign. That one is just, you take that precaution of making sure you change the sign. Now, if we graph it, if you want to do it by hand, this is how you would do it. If it's a translation, you're not going anywhere with the x, but the y, if you're adding 4, are you going up or down? Up. Okay, so what you would want to do with this point is go up 4 units. So starting at B, you count 4. 1, 2, 3, 4, and you make a point. Okay, do the same thing with the letter N. 1, 2, 3, 4, make a point. E, 1, 2, 3, 4, make a point. Now it should look like all you did was slide this up. That's all you did. All right, and then you write it with the notation. All right, and now we're going to reflect it. The reflection says that I have to flip the x and the y, or I'm going over the y-axis. If you're counting, you can just do our counting method and go across the y-axis. So here I'm going to go over the y-axis. So if E's 1 to the left, I'm going to go 1 to the right. That would be double prime because you moved it a second time. If B's 4 to the left, you go 4 to the right. That would be B double prime. And then B is 4 to the left, or N, sorry, is 4 to the left, so you go 4 to the right. That would be N double prime. And like I said yesterday, once you've done your final move, and it's more important for this one, especially if I'm grading it, is you want to make sure that that final one is shaded, so I know that was your final movement. All right, now you're going to try one. You can do it by counting like the way we did. You can do it algebraically like we did initially. If you notice, I didn't write it out for you because I want you to practice writing out the rules for yourself. And then go ahead and find me that final image. All right, what did you get for the last one? 4 and positive 4. All right, so then that would be E. And again, you can go ahead and count it if you'd like. We can go to the right 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. That would be. All right, this was your first movement. And then for your last one, you're going to go over the x-axis. So you're right, B doesn't move, so B prime would just be written over it. N is 3 below, so you go 3 above. And then E is 4 below, so you go 4 above. So this one here should be your final image. Now, you can go through and check your points, right? This one here is at 1, 0. This one's at 1, 3. And then this one over here is at 4, 4. So they're correct.